Hi, this is Veronica Henry. This demo on RAID levels is from my CompTIA Server Plus course. RAID 0 is called disk striping. And under this scheme, data is divided into blocks and distributed across all the drives in the array. Now, 2 disks are used most often, with half the data residing on each disk. And you can see that in the image on the screen, where data is distributed across both disks that are a part of this array. RAID 0 will give you improved read-write performance, but there's no redundancy. So that means, again, with RAID 0, there's no fault tolerance at all. And since there is no redundancy, if either drive fails, all the data is lost. You'll probably only want to use RAID 0 with non-mission critical data, and where you really require high speed and a low-cost implementation. Examples of where you might want to use this level are with perhaps audio and video streaming and maybe editing, or perhaps even a web server. Our next RAID level is RAID 1, and it's called mirroring and duplexing. With this level, data is actually duplicated on a second disk. The mirroring option uses a single drive controller, while duplexing uses 2, and is probably implemented less often. Unlike RAID 0, RAID 1 does feature data redundancy, so that if either drive fails, data can be read or written to the other drive. But with this level, you won't see any performance improvement, and you'll probably notice a slight write decrease. Let's take a look at this visually. As we see here with disk mirroring, we have 2 drives in the array, and the data is duplicated across both drives. And we have a single drive controller. And with this duplexing, we see that the data is still duplicated on both drives in the array, and that we have 2 disk controllers, one for each drive. Conceptually, RAID 1 is popular for those who require fault tolerance at a low cost, and without the need for top-notch read performance. So you may see this level used with financial or database applications. The next RAID level is RAID 2. Now this is an array of disks where data is striped at the bit level across all disks in the array. It has error correction, also known as Hamming code, stored on multiple parity disks. So you do get high performance and also error recovery. But you won't see RAID 2 implemented very often, as modern drives also have error correction built in. And as you can see in the image on your screen, we have 4 disks in the RAID 2 disk array, and we have 3 parity disks on the other side. So we have the data that's striped across all of the drives, and then our error correction code is here on the parity disks. And again, in terms of certification and also real-world purposes, you probably won't see RAID level 2 talked about a whole lot. RAID 3 is called striping with parity. And under this scheme, data is striped at the byte level on separate drives, while parity, which is error detection and correction code, is stored on another dedicated parity disk. And if you take a look at the image, you can see that we have the data here, striped across the 3 drives in the array, and we have the separate parity disk. With RAID 3, if any drive in the array fails, data can be recovered with the remaining blocks plus the parity information. And at the same time, read and write operations can continue. And this level gives you improved read times, especially with large chunks of data, like video, for example. And in addition, because there's only one parity drive, write operations have to be performed one at a time. RAID 3 is probably not among the most popular RAID levels either, so you may not see this one used very often. It's probably more popular for transactional type situations, or perhaps with applications with large files that require high transfer performance. And one thing to keep in mind for planning purposes is that, say for instance, you needed a total of 400 gigabytes of storage space, and each of the drives in the array are 100 gigabytes. You might think that with the 4 drives in the array, you've met your storage requirements, but actually you won't. As the last disk in the array is dedicated to parity, you can't count that one in your total available space. So you actually only have 300 gigabytes. And if you needed 400, you'd actually have to add another drive to the array. RAID 4 is very similar to RAID 3, and there are really only two differences. With RAID 4, data is striped at the block level rather than the byte level. And you'll also notice a slightly higher read performance, while write performance might be worse, again because of the single parity drive. And again, in terms of Server Plus certification and real-world application, you're not likely to see RAID Level 4 in use. That brings us to RAID Level 5, which is called striping with distributed parity. Under this scenario, data is divided into an even number of blocks with an additional parity block and striped across an odd number of disks. And you can see that in the image here on the screen. We've got 4 disks in the array, and we can see the blocks of data striped across, and here we actually have parity. And the parity block is going to be written across every drive in the array, as you can see. With RAID 5, if one drive fails, the data can be recovered with the remaining blocks plus the parity information, and read-write operations will continue until you replace the drive. So you can probably see why this is one of the more popular levels of RAID. You also have improved read-write performance because blocks are read and written to simultaneously. RAID 5 is sort of a good combination of performance, fault tolerance, and high capacity. It's best suited for transaction processing and is often used for general purpose services as well. Things like relational database application, enterprise resource planning, and other business type systems. But for write-intensive applications, RAID 1 or hybrid RAID are probably better choices, and we'll talk about the hybrids in just a moment. Because with RAID 5, write performance will actually begin to substantially decrease in write-heavy environments. Our last primary RAID level is RAID 6, and it's very similar to RAID 5, except you have 2 parity drives instead of 1. And what does this mean? It means that you can actually recover from 2 drive failures instead of 1. So we have 5 drives in the array, we have the data striped across, and we have the parity information, which is stored again on 2 drives instead of 1. So we have similar performance benefits. We've got faster recovery after a single drive failure, and the system can actually rebuild the parity information while the rest of the system is still in use. But unfortunately, this RAID level never really caught on, and it's probably because of the added expense of the extra disk. So again, this is one that you probably won't see too often.
Thanks for watching. For more information regarding our training, please visit www.trainsignal.com.